So we have seen arrays and we have also seen matrices. Now let's come to a very interesting R object which is called as vectors. So vectors are all R objects which are created using a vector. It stores the vector along with the distinct values of the element in the vector as labels. So labels are always character irrespective of whether it is numeric or character or boolean. For example, in the input vector, they are useful in statistical modeling. Now, you will say why there is a need of factors. There is a need of factors because sometimes I want to know how many headings are there. For example, how many zones are there or how many months are there. So basically the values can be in thousands, but the value is repeated again and again. So in that case, I want to find out the factors, the common values. For example, there is a list of zones and the data is like north, north, south, south, east, east, west, west. So basically the value is east, west, north, south. So in that case, I'll apply the factor function and find out the factors in a data. So to find out the factors in a data, I use the factor function. So the n levels function gives the count of the levels. That is how many factors are available. That can be done with the help of n level functions. Let's take this example and understand what it is. The concept of vector and factor. So we all know that how to create a vector. We have created a vector with the help of C function, where I have put the data green, green, yellow, red, red, red and green. So you can see over here that apple colors are either green or yellow or red, but the value is repeated. So what I'm doing, I'm creating a factor object now. How I've created factor apple equals to factor and within brackets apple colors. So what I have done, apple colors factorize apple colors. What will I get as a result? So I see. I write print the factor, that is my comment, and below that I write print and within brackets I write factor apple. So factor apple is what? It is having all the factors. And the moment I print it, see what I get as a result. I get the result as green, green, yellow, red, red, green. So this is what? This is my particular output of the factor. Now I want to print the levels. So basically the levels, when I want to print the factors, I'm getting the three values green, red and yellow. So these are the three values. Now print n levels, which means I want to print the levels, levels of the factor. So the three levels are green, red and yellow. And how many factors are there? Three factors are there. So you can see over here that my entire list was when I created one apple. When I created an apple, the data was green, green, yellow, red, red, red and green. That was my list. That was my vector which I created. But when I factorized it and stored that in factor apple, the three different values were stored which were green, red and yellow. When I printed the factors, I got the values green, red and yellow. And when I printed the level of factor apple, I got the number 3. So that is how I'm factorizing the data. Or you can say I am finding out the distinct values in a list of values. So basically I am finding out distinct values. What are the main zones? What are the main cities? What are the main codes which are available? That is how if I want to treat my data, I can always go with a factor object. Next, we have the data frames. Now, what are data frames? We are heading towards a database file. We all know that eventually we have to work on huge CSV files where we have lakhs of records and hundreds of columns. So basically, data frames are tabular data objects. That is, when I want to prepare data in the form of grid of rows and columns and I want to store information, like you can see here in the output also. So unlike a matrix, in data frame, each column can contain different modes of data. So in matrix, there was a limitation that there is similar kind of data which is available. But here, when it comes to data frames, every column can have different type of data. So the first column can be numeric, while the second can be character, and the third can be logical. Like that, I can have different types of data in different columns if I'm using the data frame. So basically, it is a list of vectors of equal length. Because how I will do it? I will create a list of vectors of equal length and store that under data frames. So data frames are created using the function data.frame brackets. Let's have a look on the code and see how we can create a data frame. create the data frame BMI, body mass index is the variable where I am creating a data frame with the help of the function data.frame. Here I have created a variable gender and I am equating that to a vector C and values male, male and female. Likewise, height and a vector 152, 171.5 and 165. I am putting a comma after every vector. That we have to ensure that if I put a comma after every vector, I am closing one vector. Then my next vector is weight, where it is 81, 93 and 78. And then there is age, which is again a vector with the values 42, 38 and 26. So these are my 4 columns which I have created with the help of a list of vectors. And all the vectors are of equal length. So basically you can see for every column there are 3 values because we are entering this value for 3 different people, 3 different, you can say, citizens. And in the end it is again same, print BMI. So the moment I print BMI, I get the output which is coming on the screen. And so easily I have created the complete information in the form of database with the help of a data frame object. You can see it is stored in a variable BMI, and when I have to print the entire grid, I'm just printing BMI and the entire data which I've created is displayed on the screen with the help of in the form of rows and columns. Now, let's have a look of some built-in functions which are very common and very frequently used in R programming. The first one is a simple example of inbuilt functions like sequence, mean, max, sum, and paste that we have seen. So if I want to create a sequence of numbers, let's say from 32 to 44, I write print within bracket sequence within bracket 32, 44. Find the mean of numbers from 25 to 82. So I write print mean 25 to 82. Find the sum of numbers 41 to 68. So that is how I can see I'm giving the range of numbers and I'm finding out the sum and mean. You can see over here that when I'm finding out the sum and mean, I'm giving the range of values, which is very similar to MS Excel also, the way we operate with sum functions over here. So when I run this on the screen, I get the desired output, which you can also see on the screen, which is coming for every print command. So if I'm printing a sequence from 32 to 44, you can see the list of values from 32 to 44 which are there. Likewise, if I'm printing mean from 25 to 82, so I'm getting a computed value which is 53.5, and which was quite a tedious task, and here I have done it so nicely. Likewise, sum of numbers from 41 to 68, it is automatically coming 1526, which is again a computation which is done by the inbuilt function sum. So these are some of the inbuilt functions that we can very easily apply on the data and print the results on the screen. Now let's talk about the power of vectorized operations. Now you must be asking, what are vectorized operations? So basically vectorized operations are nothing when I want to apply some operations on vector and see how the elements can be tweaked. So here you can see in the first line I have created a vector x which is equal to 2, 5, 1, 7, 8 and 2. Now I want to modify a specific element. Let's say x3. So I'm writing x3 equals to 11. So what will happen? Automatically 1 will be changed to 11. You can see over here when I print using subscript operator print x. So you can see the output over there in parallel using subscript operator. The original data was 251782, but in the output it is 2511782. So 1 has been replaced with 11. So that is the catch what you have to understand, that a particular value can be changed. Next is modify using different logics. That if x is greater than 9, make it 0. Which means wherever the value of x is greater than 9, convert it to 0. So you can again see the output over here. 11 was greater than 9. So there it has been again changed to 0. So in the second line of output, you can see 250782. This is called as logical indexing. We have to do the logical indexing. In that case, very easily we can change a particular value to 0. Let's say I want to ignore certain values. So in that case, I'll replace it with something else so that doesn't come. Or sometimes those numbers are outliers and I want to change that with a particular average. Let's say that is an outlier and all those exceptional outliers are disturbing my data. So in that case, if the x is greater than 9, in that case replace it with, let's say, average of rest of the values. Let's say 5. So there the data is becomes systematic and I can do good analytics. So that is how we can use. Then we have modifying the specific position by element. So how we do? Just have a look of the third last line, which is x equals to x, and within brackets I write C521. So C521, here you have seen C521. So you will see that 5, 2 and 1 are the positions where what I am looking for. So what happens? C5 is what? C5 is 8. C2 is what? C2 is 5. And C1 is what? C1 is 2. So the elements from the fifth location, the second location and the first location is printed on the screen. And you can see the output is 852. So that is how vectorized operations can be done very easily with the help of the understanding of the index and the logical conditions which are available, and how explicitly I can change a particular value. We can also change the dimensions of objects in R with the help of the dim command. So the dim has a method for data frames which returns the length of the row names, attributes of the input data, and the length of the input data is a number of rows and columns. So basically the dim is an inbuilt R function that either sets or returns a dimension of the matrix, array or data frame. So if I want to set a dimension, I can go for a dim function. The dim function takes the R object as an argument and returns its dimension. Or if you assign the value to the dim function, then it sets the dimension for that R object. So basically the idea is that suppose to get the dimension value, I will write dim and data. So I will pass the data. Now to set the particular value, I will write dim data equals to value. So I am writing a value over there. Now let's have a quick look on the example. Suppose RV is a variable and I am writing REP is a function, and then I write 1 to 10 and then I print RV. Likewise, if I say dim RV is equal to C2, 5 and then RV. So here what I am doing, I am assigning RV 2, 5, which means the dimension is 2, 5. So that is how I can change the dimensions. So mainly dimension function, it will take R object as an argument and return its dimension, or if you assign the value to the dim function, then it sets the dimension for that R object. So students, with this we end the session 1 for the introduction to R programming. I would request you all to load the compiler so that you can try the programs which have been discussed over here and run those programs on the compiler and gain some confidence.